out of the X-ray too. Absolutely. But you're saying it, and I know it sounds so simple, but people will continue to see this as two currents, and it is not. They are two separate things. Tube current is the flow of electrons from cathode to anode. The X-ray beam comes out of the X-ray tube. This is what we're using on patients to create an image. Okay? There's also going to be overlapping processes that result in creating the radiographic image. Okay? So there is a lot going on. Your objectives. This is your objectives. This is what it's basically telling you. We are going to discuss a lot of properties. However, you've already covered where the electrons come from. You've already covered what they're going to collide with. And you've already covered where they're going to exit from. The X-rays are going to exit from. Okay? I want you, before I actually get into the interactions, I need you to go back in your understanding what does ionization mean? What does ionizing mean? Let's go back to terms. What does ionizing mean?
Ionizing, it means
you separate the electrons from the atoms.
So we're separating, or we're liberating, or we're removing, however you want to say it, removing an electron from its orbit. Its orbit. So in this section, remember how I said I was going to introduce some items for your understanding? We're going to start off with the tungsten atom. I need you to see what the makeup of what a tungsten atom looks like. Okay, because when we start talking about these two types of interactions, the electron is going to interact with the tungsten atom differently. So I'm going to open up with going over what is a tungsten atom.
Ms. Lauren?
Yes?
I just want to tell you, Luke is trying to get back into the meeting. He just texted me.
Thank you. You know what? Let me see. It's not showing for me to admit, but I think it's... I'm trying to... I guess it's locked after a certain... Let's see if it's here. Okay. You should be able... Okay. You should be able to... There you are. Hey, Luke. Okay. So, I need you to go back and look at your key terms. We're going to talk about ionizing radiation. I know that some of you have already started on your chapter 6. I need you to pay attention on your chapter 1 and your chapter 5, because I'm going to start incorporating a lot of those words into chapter 6, because now we're talking about interactions. Yes, we talked thermionic emission is a process because we boiled the filament so hot that electrons boiled off. Forever and a day, you will know what thermionic emission is, correct? Yes? We also talked about the collision, the conversion of the electrons with the focal track. Two energies emerge. Kinetic energy has been converted into two types of energies, thermal energy, and electromagnetic energy, which is X-ray. Okay? But before we get there, we're going to start talking about the atomic makeup of a tungsten atom, the orbital shells, how many shells, and we're going to talk about binding energy. Binding energy. Okay? Binding energy because it has a value. Binding energy of the electrons has a value. Okay, so I'm going to go ahead and stop class here. I need y'all to be well aware that I am going to be approaching the tungsten. If you need to talk to me about this test, I'm here for the next 30 minutes, and then I'm going to be making my way downstairs to go and see the radiology director, just to kind of touch bases with them. So if you need to talk to me, or you need to schedule a tutoring, okay, we need to go ahead and get that into place now. All right? Any questions? Okay. I'm giving you extra time so you can start looking at your words again and recapping and be ready for Wednesday. Wednesday, we have your pathology exam, and we're going to be hitting chapter 6 full. Half the speed of light. Okay. No jokes today, a little bit. All right, maybe next time. All right, guys, if you have any questions, thank you, Daniel. I appreciate that. I'm here every Monday and Wednesday and Friday. All right, I'll see you guys later. Bye.